benefit. When you are looking at resources, you are actually reducing your natural resources all the time. Your systems are drying up. So that's an important thing to look at. And the leaching process and the runoff of fertilizers and pesticides, they pollute. When you are using chemical fertilizers, the plant can only pick up maximum 40%. Goes into the groundwater or is just building up and salinity in the soil. So this is one of the key problems of the modern agriculture. So what nobody really is talking seriously about is the healthcare effect. You are destroying your own system of immunization because you are destroying the system of immunization of the plants. So you are eating plants, you are eating food that is not supporting your system of immunization. That's the consequence. And now the climate, what is the climate doing? It's worsening the whole situation. It's speeding up the problems. The changing rainfall patterns, the dry span that cannot be calculated anymore are creating a lot of problems. A lot of problems for whom? First of all, for all those who only have seasonal crops. They are in here. You all get these PowerPoint presentations at the end, so it's not needed that you note down every single word. And one of the problems we have when we are looking at the situation in Uganda, you only have 9% forest left. And you have 40 million of people who are cooking with charcoal or with fuel wood. But who is planting trees? None of these people is planting a tree. When you cut down a tree, how many trees do you have to plant when you are cutting down a 20 years old tree? What do you think? 10? Who is for 10? Who is for 50? Who is for 100? So how much? Minimum 2,000 trees you have to plant to replace one existing tree. Balance the effect. That is when you have 100 years old trees, you have to plant 20,000 trees. Balance the effect. So people don't think about that. So the carbon dioxide emissions, they are increasing. Of course, you see that where are the cities growing? On the bad land? No. They grow on the good agricultural land. So that's the next problem. You have a fast-growing population, you see. People are constructing their houses in the best agricultural land. So that's also increasing. And what is the consequence? Increased temperature. What is increased temperature causing? Plants. What does stress for the plants mean? Pests. Weak plants are attacked by insects. Healthy plants are not attacked by insects. When you weaken your whole system, then you have a lot of problems. But one of the big issues, you see it also here in Uganda, the runoff of the water. When you remove the trees, you are dehydrating your land. You are not able to put the rainfall down into the soil, into the rocks anymore. It flows away on the surface. And now you have dried up your wetlands. So where does the water go? You have floods. And you see it in the cities also, close to city areas. And you have landslides. It's just washing away everything. So please think about the consequences. And what happens when you add salt to your soils? Fertilizers are salts mainly.
What happens? When you are eating more salt, what happens? You need to drink, huh? You need to drink. So what happens when you are using salt as fertilizer to the plant?
More water.
You need more water, that the plants can pick it up. So you are actually disturbing the whole system like that. Next, please, yeah. Now let's have a look. You see, that's today's agriculture when we grow monocultural system. We can also grow monoculture in organic farming. Actually, a large part of organic farming is done in monocultural systems. So, but what happens? Look at these sketches. What happens when you have a monoculture structure? All plants are at the same level. So the access for light and carbon dioxide is maximum competition. What happens in the soil? All roots are on the same level. Maximum competition. And people always try to explain us, you are creating competition when we are adding a tree where the root systems are not at the same level as the seasonal crops are. Next, please. Now we are talking about solutions with agroforestry. What does it mean when we are planting plants that cover different levels? You have a pyramid above, which is access to light and carbon dioxide, and you have a pyramid in the soil, within the soil, which is different root systems. In the soil, it's about access to water and nutrients. So what makes the difference? Here you have a dynamic development. In the monoculture, you always remain at the same level of the system. It's placenta stage. You are not creating a dynamic development. But here, every year, things are going to change. Every year, you have changes in your system. Next, please. So to summarize a bit what it actually means, you see, when you have a monocultural system, the architectural structure is you have a single layer. The vegetation cover is seasonal. That means once you have harvested, a lot of your field is just open, fully exposed to the sun. The resource flow is you depend on external inputs, whether it is organic or non-organic. Doesn't matter. But you depend either on fertilizer or on compost or on other external inputs you actually have. What is the soil management? It's a mining process. You are taking out, but you are not putting back. So a mine, sometime it ends. When you have removed all the nutrients from the soil, it ends. And so you are actually degrading your structure. And then when we are looking at the microbial effects, the soil life, the microbes, they are the key thing for agriculture. You will see that throughout this workshop. What happens? When you are using glyphosate, what is glyphosate? It's a herbicide. Huh? What is the impact of glyphosate? It's an antibiotic. What does antibiotic mean? Antibiotic, killing life, ending life, ending microbes, killing microbes. When we are looking at the regenerative agroforestry structures, we have in a multi-layer system with permanent vegetation. Permanent vegetation means that you have full year photosynthesis. You have plants that are supplying food for the microbes in the soil the full year. When you only have seasonal crops, when there is nothing, no green plants on your soil anymore, there is no photosynthesis happening, so there is no energy in your soil. So it's an internal cycling we are promoting. We want to cycle everything what we are growing. We put back all the residues. We are not removing anything. We are putting it back. Only what we harvest, but this is much less compared to what is existing in the field. So it's building up the soil, and it's a probiotic system. We are encouraging multiplying life, not reducing or killing life. Next, please. Our goal is always to mimic the forest. Does a forest need fertilization? Does a forest need pesticide? Does a forest need irrigation? So our goal is to come to that stage. Self-regulating systems. And that is our approach. At the end, when we are doing a good job, we end up at this situation. And you will see some examples here, how this can work. Next, please. What is the basis of agriculture? We have three main cycles we have to carefully look at. We have the water cycle, we have the carbon, and we have the nutrient cycles. These are the three main cycles that have the biggest influence on what you are doing in agriculture. Next, please. So, water, every life starts with water. There is no life without water. So water is the most limiting factor. When you don't have water, when you don't have humidity, all the other parts of the processes, the carbon dioxide process does not function properly, the nutrient cycle does not function properly. When you have a dry soil, the photosynthesis does not function anymore in a proper way. So water is the most limiting factor. So all our efforts we are trying to do is to keep moisture in our systems. That's one of the key aspects we have to look at. So the carbon, you see that the current problem we have with increasing carbon dioxide is not about emission. It's completely wrong understanding from my point of view. It's not about the emissions. It's the problem of deforestation and reducing the sequestration process. Because the gap between what we are emitting and what we are able to sequester is increasing every year. And the problem is the sequestration goes down in a faster way than the emissions are going up. And this is one of the key problems. But politicians only try to reduce emissions. They don't try to increase sequestration, which actually is happening. The more plants you have, the more carbon dioxide you are sequestering. So the nutrient cycles, they are steered with the microbes. So you can see that actually most of the aspects, they depend on the microbes. Because the microbes, again, they need water. When they don't have water, they can't survive. They need the photosynthesis because that is the feeding of the microbes. So all these cycles, they are interdependent. We cannot isolate one, and we cannot think, you see, when you try to add fertilizer, you think you can isolate the nutrient cycle. That is stupid, because these cycles are all interdependent. So next, please. These are pictures from Malawi. First they have sown, this is actually from 25. First they have sown the maize, then they have heavy flooding, all the maize is gone. Then it dried up, they have planted again, and after the rain, and they had a dry span, again it dries up. Either too much or too little water. To manage the water flow is one of the big problems in agriculture. So that's a key thing. Next, please. Where does it start when we are looking at the water cycles? We try to keep the water in the landscape. Currently, we are trying to speed up the flow of the water out from the landscape. We channelize the water, that it flows out, because we are not able to control it anymore. In India, for more than 30 years, we have an approach, it's called watershed development, where we are structuring the landscapes. I have assisted such kind of projects for 15 years. And I have learned that completely dehydrated areas you can regenerate actually in 3 years time when you are able to collect the rainwater. So to collect the rainwater means you are digging trenches along the contours, you are terracing the landscape, you are putting up small check dams to store the water that from there you can irrigate in the surrounding areas. Next, please. An important aspect is keeping the moisture, keeping the water in the landscape. What does it mean? What happens when we have no trees? What happens when you have heavy rainfall? No trees. Washed away. Do you recharge the groundwater? Very little, very little. So what happens with your groundwater system? You can't recharge it when the surface water always flows back. Now, an interesting thing is, you see, when you have about 10 to 20% of trees, it's the optimum to recharge your groundwater sources. That's what we have learned in India, really. That is really the biggest impact in recharging your wells is when you have about 10 to 20% trees. Why is not the forest the one that is recharging your wells? Where does the water remain in the forest? It's in the plants, but you have a lot of water in the topsoil because of the root system. The root system is storing a lot of water. So the forests are mainly resourcing the surface water, the rivers, the lakes, but they are weaker in recharging groundwater. I have done bore well drilling. I have done more than 100 drillings in India. I have done a lot of drillings in other countries. The most difficult place to find water is a tropical forest. The easiest thing to find water is the desert, because there you can identify it easily. But it's the problem of the recharge. So what we can see here in the area in Luvero, it used to be forest. Now the trees have gone. The water runs away on the surface, but it does not recharge. And you have a lot of basalts. You have a lot of structures where you can't store a lot of groundwater. So it's very difficult to have a groundwater supply for irrigation. Very difficult, but actually we don't need it. Next, please. Now, storing water can happen artificially. You are doing it, you are terracing. The structure you see here in the Western Ghats in India, the terraced landscape is filling up. That's where they are growing the rice. Like this, you are storing. When you structure this landscape at the beginning, the people down, they are complaining. 3 years later, they tell you, thank you so much, you are controlling the water, but we are getting the water again. At the beginning, people don't understand how the system works. But there is a natural way in dealing with the water. It's called hydraulic lift system. Can anybody imagine what it means, a hydraulic lift system by plants? Gordons?
Yeah. You have, in the air, you have relative humidity, and compared to that relative humidity, the tree will emit water out into the air. It's like sweating. And through that process, it can pull out water out of the ground. And so if the difference is bigger, it's going to pull more. And if the difference is smaller, it's going to pull less. And if in the air there's more water than in the soil, then it's going to push down the water into the soil and re-wet the soil. So it's like a syringe, if you know, to put medicine somewhere, and you can pull it in both ways, and you can put water down or up.
That is part of the explanation. Now we still have to add the plants. What is the function of and what is the structure of the different plants? We have specific plants that have a root system that has a deep taproot and horizontal roots. Why is this the key to the hydraulic lift system? You see, the taproot can bring up water from deep horizons, and the horizontal roots, they are going to distribute it to the level of other plants. Now we have special plants who have this ability, and they are important pioneers when we are working in desert areas, but even here. And one of the trees, everybody is always trying to say, this is a bad tree. It's eucalyptus. Eucalyptus is one of the best pioneers we know, because they have this system of hydraulic lift. Eucalyptus is becoming a problem when you plant eucalyptus. Then the top root system is like this, and you cannot plant anything. But when you are surrounding the eucalyptus with other fast-growing plants, the roots go deeper. And you can always plant anything next to the eucalyptus. We have other plants that have this hydraulic lift system. An important thing is what he was mentioning, and when you have heavy rainfall, the root system helps to bring down the water. And when it is dry, they bring it up again. And this is basically happening through the opening and closing of the stomata. And this is creating this pulling pressure to bring the water. So that is there are other plants that are important in this. And you will see these are mainly pioneers. Castor, neem, they have the same. Pigeon pea, they have the same. So when you look at these plants, when you start planting somewhere where you have limited amount of water, you always try to take plants, to combine plants with a specific hydraulic lift competence and combine them with other plants. That's an important part. Next step. So the vegetation, if you don't have vegetation, the green water cycle cannot function. So green water cycle means storing and re-emitting. When water percolates, when water is being used by the plants, it evaporates through the transpiration. And it condensates again at night when you have a certain temperature difference, or it comes back as rain. 50% of the rain does not come from the humidity over the sea, but it comes from the humidity over the landscape. That means from the forest. The forests, they are steering the movement of the air. A forest is a cooler place. So what is happening when you, how is air moving? Hot to cold or cold to hot? Hot to cold. So what happens? What happens when you have a canopy system and it's getting, where is the heat? It's on top of the canopy. Where is it cold or cool? Down. How is the air circulating within this system? It comes down. It comes down because the hot air on top is coming down. So you keep, when you have a canopy structure, a forest-like structure, you keep much more moisture in the system. When you have a monocultural system, all the humidity, it goes up and it never comes back. The whole condensation process does not happen. All these things, they don't happen. I started recognizing this when I was once pruning 800 moringa trees in a closed system. I was like sweating like mad, but I had cool feet. There I started realizing, oh, what is happening here? Keep that in mind because it helps you to keep much more moisture in your system when you have a canopy structure. Next, please. I have already mentioned this transpiration and condensation. I think we can see that one of the important things I want you to look at carefully is how does carbon come into the soil? You have two main cycles. One cycle is plant material is decomposing, but what is happening when during the decomposing process? More than half is going back to the air, it oxidizes again. What is happening when you have a living plant? Eric?
When you have a living plant, during the process, carbon is stored into the soil when they trap that gas during the process of making their food, stored back to the soil.
The carbon that comes through the photosynthesis of the living plants to the soil as exudate, the microbes, they are picking it up. The microbes, they have carbon dioxide, they store water. Like this, the root system is working 5 times faster than decomposing processes. And as you can see, there is much less oxidation happening because there is no air down here, or not much air in the soil. So having living plants means that's where you store a lot of carbon. Only decomposing things means a lot of your carbon goes back to the atmosphere. So the efficiency in carbon sequestration comes from living plants and not from the composting. That's something we need to understand. How can it be that the people in Egypt have a similar problem as the people have it here? See, in Egypt, in Wahab, they are using about 1,800 millimeters of water per year to grow 2 seasonal crops. In Uganda, you have about 1,800 millimeters of rain per year, but the productivity is about 5 to 10 times higher than it is in Egypt. How does it come? What happens with the water in the desert?
In arid zone, most of water quantity is evaporated, ruling. And
Depending, we must say, depending on how you irrigate. There are ways how you can store more water and reduce evaporation. That's something we still will see. But what you see when you look at, we have a common problem in both areas, a lot of water. What does it mean when we are adding a lot of water into the soil? There's a lot of leaching happening. See in Wahat, they are irrigating with potable water, and when it comes out further down, you cannot drink that water anymore. And they do organic farming, they do biodynamic farming. Why is it happening? Too much water. It leaches. Because the plant, the problem in Wahat is the lack of biomass. It's the lack of biomass. But in Uganda, we have a similar problem because of the high rainfall. When you have monocultural systems, water goes through.
due to less biomass.
Yes, but the problem is also because of this heavy rain, we need to add much more biomass because the decomposing process is much faster. So it's easier to maintain a soil quality in the temperate climate. It's a bit less easy to do it in the desert, but in the desert it's still easier than to do it here. So people always think you are in the tropics, very easy, everything is green, you have everything. It's not so easy because it's a lot of rain, and when you only go for monocrops, you are also increasing the leaching. Next, please. What people normally don't understand, you see, the farmer is the biggest solar entrepreneur. Why? What are the leaves? What are the leaves? The leaves are the solar cells. What is the soil? The battery. The battery. So when your soil is not functioning properly, the battery is not functioning properly. When you don't have moisture in the soil, the energy cannot be stored. So that is the difference you see here. Do you have energy in the soil? No energy in the soil. You have energy in the soil. It's the same place 4 months later. It's a massive transformation of the storage capacity of the soils concerning energy. And the energy need, here I have a lot of microbes, here I don't have. They are not fed. You are not feeding the microbes there. So it is important to understand, you see, all your leaves, these are solar cells. The more leaves you have, the more energy you get. Simple. So you just have to manage it. And nature is giving this for free. The entrepreneur in Europe, he needs to buy solar cells. He has large expenses. You get that for free here. Huh? That's something you need to look at. Next, please. Now we are coming to one of the most important subjects you will see throughout the whole training. It's about microbes. These tiny things, they are actually steering whether you are successful in agriculture or not. It's the key thing, and we need to understand that microbes are everywhere. Same on your body. Why do you smell something? Because of microbes. If there wouldn't be any microbes, you take sand and you smell, there is no smell because there are no microbes there. When your skin is not smelling, you have tried to kill the microbes. But actually, everybody is smelling because you are sweating, your skin is breathing. So, but it's the taste and the flavor and all these things, they come through the microbes. And you have microbes outside of the plant, in the leaves, you have them in the air, you have them inside the plants, you have them in the soil. They are everywhere, everywhere. So it's important to understand how are we going to deal with these creatures. You see the bacteria and the fungi, they exist millions of years longer than human beings and other plants actually are existing. So what do you think when we are fighting with drought and with flood? Who can help us to deal with these situations? Who has an experience on that level? Bacteria and fungi. So when we want to fight with drought and flooding, we need to have an eye on the microbes because the microbes, they will guide us what we can do. But how do you get microbes? How do you get microbes into the soil?
By reducing the monocropping.
Yes, when you also have microbes when you have monocrop, but you don't have a lot. And when you are using the fertilizers and the pesticides, you are killing them. And so the more, each plant has a different combination of microbes. So when you are planting a lot of different plants, you get a lot of different microbes. Yes. So they are key. The microbial activity is actually key for soil fertility, plant health, and crop productivity. Next, please. Because at the end, you see, when you have no organic matter in your soil, you cannot manage the fertility and the health of the soil. What does fertility mean? We have three main components. We have a physical fertility. What does physical fertility mean?
The richness of the nutrients, micronutrients.
That is chemical more than the physical is aeration, the aeration and humidity of the soil. When you don't have aeration, when you have clay soil and you don't have enough vegetation, you have no aeration, so you don't have physical fertility. It's the porosity, the aggregate formation. This is basically on the physical side. The chemical is the nutrients, the compounds of what. But the biological fertility is key to physical and to chemical fertility because they make it happen. Without life in your soil, there is no real chemical fertility, there is no, especially no physical fertility. The earthworms are helping to dig. You don't need to plow, the earthworms are doing it. So it's understanding that all these things, they depend on your microbes and your living organisms in the soil. So you have to protect and to promote them and not to kill them. Next, please.
Yeah, go back a bit. I think most of you are aware of the soil tests happening currently. What do they test for? So they will tell you NPK content in your soil, right? That's usually the main experiment, the main soil tests you are doing in laboratories, in soil laboratories. Do you think that's all it takes? And do you know why it has been designed that way? Because they want to sell you the NPK. So they have to make sure you know that your NPK is not up to the value you need in your soil. So you will go and buy urea, you will go and buy whatever you buy. But if you understand how soil health works, and you have enough biological fertility, that is a diversity of microbes in your soil, each microbe avails different nutrients. You will see that on Thursday. So for us, we believe mainly in one aspect, if you are checking soil health, the biology of your soil. If your biology is functioning, all the rest will function automatically. And to us, we believe that's the main test you have to do on your soil, not the other ones. The moment you have that biological fertility, all the rest happen naturally because they are the drivers. Thank you.
So the soil, we need to understand that every health starts with the soil health. But how do we get soil health? Only through the biodiversity and the biomass. But the functions of the soil, they are relevant for so many developments within. It is a water storage. It steers water flow, water filtration. You see, the soils, they are your wastewater plants together with the plants you have. They are cleaning your water. So it is essential that we understand it. They decompose residues, they influence the atmospheric composition. Because when you have a rich soil, you go to the forest. What is the difference when you walk through the forest or through an open field? What can you smell? And why do you smell? Because you have the humidity. When you are in an open field, the humidity, you don't realize it because it goes up. But in the forest, the humidity remains in the system. So it helps a lot. But what we are currently learning a lot is actually to detoxify the soil is one of the key aspects we can look at, and we have specific plants that can steer the phytoremediation, as we call it. That means we can change toxic elements in the soils. We can control pathogenic aspects in the soil. So detoxifying pollutants, it becomes more and more important because a lot of soils are polluted through pesticides, through other ingredients. And you have a lot of mining problems. So the soils can together with the plants, they can suppress pathogenic impacts. We have thousands of deadly chemical compounds and viruses in the soil. But why are people not dying? Because in the soil, in a healthy soil, it's balanced.